Okay, so by request, I'm going to go ahead and do the Chapter 3A review by video. And so kicking off number one, this is our quite straightforward little power rule. Remember that our derivative of any kind of polynomial, the derivative of x to the n power was n times x to the n minus 1 is how we're going to kick that off. So our first derivative would be 48x cubed minus 6x. And again, instead of thinking about this as 4 over x, which would lead us into a quotient rule, I think I'm going to think of this part as 4x to the minus 1. So that would be minus 4x to the minus 2, which is actually a completely legitimate answer. Or possibly a slightly better answer would be to make it 48x cubed minus 6x minus 4 over x squared. Good to go. Okay, now, of course, for letter B, we're going to think about this as the product rule as FG. So if you recall, the product rule was F prime G plus G prime F. So F prime, of course, is 5. G is, of course, the tangent of X. G prime, this is one of those memorized facts. The derivative of the tangent is the secant squared of X. And F itself is 5x plus 7. And there's really not much I can do to make that one look better. It just sort of is what it is. Now, moving into letter C is where we're going to get into our little quotient rule, which is our low, D, high thing. So we're going to have our low, D high, the derivative of the numerator is just plain old-fashioned 3, minus high. And of course, our D low is 3x squared plus 4. So here's my low D high minus high D low. We're going to square the bottom, and away we go. Now, this particular problem, I know a couple people did try to simplify it out a little bit. Unfortunately, not much really very good happens in this problem. If you do some manipulation on it, you can get the following out of it. You do have negative 6x cubed because we have 3x cubed here and minus 9x cubed there. There's 12x squareds on top and a 16. And, you know, by doing a little bit of math, I could make this happen. But unfortunately, it's not particularly better than where the problem began. It's churning. Now, for letter D, again, we're going to do F prime G plus G prime F. And F prime, I saw a lot of people struggling with this one, but F prime is just 15 cosine X. G plus G prime F. Now, this one, you could theoretically leave it, but standard protocol, because we have multiple terms here that have that e to the x, is we would usually factor an e to the x out, which is going to leave me with a 15 cosine, a 15 sine, and a minus 1. That is probably the optimal answer in that particular story. Now, for letter E, I could do this as a quotient rule, but like what we said in class, if we instead think of this as taking the derivative of x plus 1 to the minus 1, remember, you drop the exponent down, you drop the exponent by 1, and then the derivative of what's inside, of course, is just the number 1. So we're pretty much done with the first derivative. Now, if I want to take the derivative of this would be the derivative of this guy. Again, just like before, we're going to go ahead. Let me fix this little stray mark that makes it look like a 21. Negative 2 times negative 1 is 2x plus 1 to the minus 3 times the derivative of what's inside. And that, of course, is going to be, this is f double prime of x, also known as d squared y dx squared. Just different versions of how we say things. Now, we did do number 2a in class, but again, I'll have it here on this video, so we just have it long term. It says the formal definition, so we want to do the limit as h goes to 0. We're going to do k of x plus h, which would be, here is x plus h minus k of x itself. all over h. And again, the limit as h goes to 0. This is honestly the worst case scenario. I hate it when we have these quotients just because they get so long. So we're going to go ahead and hit this thing with a great big fraction buster. And the whole reason we did that is because when this fraction hits this, the x plus h minus 5 would cancel, and we just have x plus h plus 2 times x minus 5. And over here on this other side, the x minus 5 would cancel, and I have my x plus 2 times x plus h minus 5, all over h, x plus h minus 5 and x minus 5. Again, this is still the limit as h goes to 0. I, like you, do get a little lazy and sometimes don't feel like writing that limit in. Now, this is just kind of tedious, busy work. We still have our h, our x plus h minus 5 in the bottom. And here comes the fun part. When we start distributing, we'd have x squared minus 5x. I distributed the x to both of them. Now I'm going to distribute the h to both of them. I'll have hx minus 5h. hx minus 5h. Then I'm going to distribute the 2x minus 10. Now over here, I have to be really careful about distributing that negative. I'm going to have a negative x squared. I'm going to have a negative xh. I'm going to have a positive 5x. I think I've distributed this negative x onto over. And then the negative 2, which is going to be a negative 2x and negative 2h. And last but not least, a positive 10. It's so long, I'm kind of running out of room to write. So now let's see if we can do a little shooting gallery and make a lot of things go away. We're going to notice that the x squareds go. I notice right away that the 10s go. The 2x's go. The 5x's go. This doesn't happen in every circumstance, but in this particular one, I think even the xh's go because I made a mistake right here. This was a positive xh. The xh's go. And when it's all said and done, I have a negative 7h right here. And so if the entire numerator comes down to negative 7h, I could cancel the h's, and I'm down to the limit as h goes to 0 of negative 7 over x plus h minus 5 times x minus 5. But as h goes to 0, this is just x minus 5 times x minus 5, which is x minus 5 quantity squared. And that is our derivative of our big nasty quotient. So to finish off number 2, we wanted to find, we now know what k prime of x was. So if we plugged in the number 6 minus 5 is just 1. And so I think k prime of 6 would be negative 7 over 1 squared, or just plain old negative 7. Now, to finish our story, every time you need a tangent, you need a point and you need a slope. Well, in this problem, we already know that the slope is negative 7, but we want to find out what happens if I plug in the number 6 into the original problem. And if I plug in 6 into the original problem, what you'll see is we get 6 plus 2 are 8. 6 minus 5 is 1. 8 over 1 is 8. So I now have a point and I have a slope. So it's going to be y minus 8. It's going to be x minus 6 with a negative 7. And that is the point slope form of my tangent. And so that's the first 2 questions on the review. And I will pick up at number 3 on another. So I'll see you on the next one.